Okay, welcome to the second video for our prerequisite chapter of Honors Geometry. Here we're going to do a whirlwind review of solving linear equations. So essentially it doesn't matter what kind of linear equation we are solving, it boils down to a four-step process. Doesn't matter how complicated, how big, how ugly, it is always four steps. And I always like to use the acronym ECID, E-C-I-D. I'll explain what that means here. So E stands for expand. Okay, what that's telling you to do is get rid of parentheses. By multiplying stuff out. In other words, we're going to distribute first to eliminate any and all parentheses. Okay? Secondly is C, which stands for combine like terms. Remember that means on each side of the equation. So we'll combine the like terms on the left side and combine the like terms on the right side. Next up is I for isolate the variable. That stands for, what I mean by that is move the variable, x usually, move the variable to one side and the number to the other. And then that should result in a one-step equation, so the D stands for divide. And I've got a couple of examples that we're going to run through here. And it really will be fast. The advantage of this being on video is that you can always easily pause the video or go back and watch it again. So these first two are two-step equations. They don't have anything to expand. There are no parentheses. They don't have any like terms that need to be combined on either side. So we move directly to step 3, which is to isolate the variable. So what we need to do here is we need the negative 11x by itself. So we're going to subtract 33 from each side of the equation, which will result in negative 44 equals negative 11x. So negative 44 equals negative 11x. Notice that now we have a one-step equation, and all we need to do to finish solving it is divide by negative 11. Negative 44 divided by negative 11, a negative divided by a negative is a positive. 44 divided by 11 is 4. So our answer is x equals 4. Same thing on this next example. We need the 4x to be by itself, so we subtract 8 from each side of the equation to get the 8 off of the right side. That gives us negative 20 equals 4x. Remember, that is a one-step equation. We divide by 4, and we get negative 5 equals x, or x equals negative 5. So we don't always have all four steps. Again, if there are parentheses, we take care of them first. If there are like terms, we take care of that second. Then we isolate our variable, and then we divide. Okay, four-step process. So let's look at some slightly harder problems. We still don't have anything to expand in the top left equation. We still don't have anything to combine. However, now we have a variable on both sides. So what we need to do is move the variable to one side or the other. It does not make any difference at all which direction we move our variable. I prefer to end up with a positive variable value, so I'm going to add 10x to each side. You could just as easily add 7x to each side, and you should get the same answer either way. Now while we're at it, if we're moving the variable to the left side, we should also move the number to the right side. So we're also going to add 8 to each side at the same time. This results in 3x equals 12. Again, we've got ourselves a one-step equation, so we divide both sides by 3, which gives us our answer, x equals 4. Let's do another one exactly like it. Again, we don't have any parentheses. We don't have any like terms to combine. So here, I would move the x to the right by adding 2x to each side, which means I need to move the number by adding 21. That would give me 15 equals 5x, divide by 5, and we have x equals 3, or 3 equals x. On to the next example. There we finally got some expanding to do. So again, when we say expand, what we're saying is distribute. We're going to take negative 2, and we're going to multiply those first two things by negative 2. That would be 6x plus 2, and then we still have the rest of the equation, minus 4x plus 3 equals 25. Then we are going to go in here, and we are going to combine like terms. So we have on the left side a 6x and a 4x that can be combined to be 2x. And we have a 2 and a 3, which would combine to equal 5. Now the right side of that equation doesn't have any like terms, so we just leave it alone in this step, giving us 2x plus 5 equals 25. Now we're down to a two-step equation like the previous four examples. We're going to move the 5 by subtracting 5 from each side, which will isolate our variable and give us 2x equals 20. And then divide by 2, which gives us x equals 10. Next example is almost exactly the same. Again, I would suggest you pause the video and try on your own if you're learning this for the first time. We're going to distribute the negative 4 as our first step. That would give us negative 8x minus 20. And then we still have plus x plus 2 equals negative 11. We're going to go in and combine like terms. We've got a negative 8x and a positive 1x. That would be negative 7x. And we have a negative 20 and a positive 2, which would be negative 18. I'm going to add another line underneath those just so they look different even in black and white. Okay, and that would equal negative 11. So then we would go in here and we would add 18 to each side to get the x term by itself, giving us negative 7x equals 7, and divide by negative 7, which gives us x equals negative 1. Couple more examples. Okay, so this next one is similar to the two we've already done, so we'll do this one very quickly. We're going to distribute the 5, which gives us negative 10x minus 20. We're going to keep everything else the same. Minus 2x plus 2 equals negative 42. We are then going to go in and combine like terms. So we have on the left side negative 10x and negative 2x, which would be negative 12x. And we have negative 20 and positive 2, which would be negative 18. And that will still equal negative 42. Add 18 to each side to isolate the variable, because that's our next step. We've expanded, we've combined, now we isolate. That gives us negative 12x equals negative 24. Divide by negative 12, and we get x equals 2. Now the thing about linear equations is the more complex they get, the more options you have for how to solve them. So our next equation here contains a fraction, and there are multiple ways to do this problem. But I'm going to show the approach that is going to be used by the program that we are going to be using for our assignment on this, deltamath.com. You should have already registered for this. If you didn't, contact me via email. We'll get you hooked up. Okay, but I want to show you the exact method that they're going to show you if you choose their help videos, because I don't want you to get confused. So for them, they're still going to follow my lead, which is distribute the 4/3. Now when we do that, we end up with 4 equals 4/3 x minus, and then 4/3 times 6 is 4 times 6 divided by 3, which would be 24 divided by 3, or 8. Then they are going to tell you to clear the fraction. So if you look, we've only got one fraction there. Its denominator is 3. So what we're going to do is we're going to multiply all 3 terms of that equation by 3. We're going to do 3 times 4, 3 times 4/3 x, and 3 times 8. When we do that, what happens is the 3's will cancel in that middle term and leave us with 12 equals 4x minus 24, which is a two-step equation. We've done about 6 or 7 of those already. So now we're going to isolate the variable by adding 24 to each side, which would give us 36 equals 4x. And then we're going to divide by 4, which will give us x equals 9. Again, anytime you're unsure as to whether or not your answer is correct, you can always take the x value and plug it back in to see if the equation is true. Let's do a couple more fraction examples. I don't know that we'll do all 4, but we probably should. I think this is also the last slide of this one, which it is. Okay, so if I never get it to go back, there we go. Again, we're going to start off by distributing the fraction, 1/4 times x, 1/4 times 16. That gives us 8 equals 1/4 x plus 4. 1/4 times 16 is 1 times 16 divided by 4, which is 16 divided by 4, or 4. Then we are going to multiply everything in that equation by 4. Okay, so we're going to do 4 times 8 equals 4 times 1/4 x plus 4 times 4. That would be 32 equals, the 4's in the second term will cancel, giving us with 1x plus 16. And this 1 is not necessary. You can just say x plus 16, same thing. Okay, then we're going to subtract 16 from each side to isolate the variable. And that gives us x equals 16. On the next one, we distribute the 8/5. That gives us 9 equals 8/5 x plus 8. Then we're going to multiply everything by 5. So 5 times 9 equals 5 times 8/5 x plus 5 times 8. Again, the 5's will cancel in the middle term, giving us 45 equals 8x plus 40. Now this is actually a great example to look at because when we go to isolate our variable, we end up for the first time in this lesson ending up with a one-step equation that does not divide evenly. When we divide 5 by 8, 5 is not divisible by 8. Please keep in mind it is not even rare for a problem that contains fractions to end up with a fractional answer. Now technically speaking, this is equal to an exact decimal of 0.625, but I want the fraction. Okay, the only exception to that is if the problem contains decimals to start with, then you may use decimals. Otherwise, I want fractions. 2 examples to go. Let's go through them. 1/2 times 9x, 1/2 times -6. That will give us 13 equals 9/2 x minus 3. And you could write that as 9x over 2. It is the same exact thing. We are then going to multiply all 3 terms of that by 2. So 2 times 13, 2 times 9/2 x, and 2 times 3. So 2 times 13 is 2 times 9/2 x minus 2 times 3. Again, the fractional part, the 2 will cancel with the denominator. And then we multiply what's left, leaving us with 26 equals 9x minus 6. We're going to add 6 to each side, which will give us 32 equals 9x. Then we're going to divide by 9. Once again, 32 is not a number that is divisible by 9. So we have x equals 32 over 9. Now please be careful to check and make sure that your fractions do not reduce. This one does not reduce, so we're good there. And we move on to the next one. This is our final example. 3/4 times 5x, 3/4 times 20 is 8 equals 15x over 4 plus 3/4 of 20, which is 15. We're then going to multiply everything by 4. So 4 times 8 equals 4 times 15x over 4 plus 4 times 15. Once again, when we do that, the 4's in the fraction and in front of the fraction will cancel each other out. I'm trying to get the right color coding here so it matches the rest of the notes. There we go. And we have 32 equals 15x plus 60. Subtract 60 from each side. Gives us negative 28 equals 15x. Divide by 15. And once again we end up with a fraction. So x is negative 28 divided by 15. Once again, that fraction does not reduce, so that is our final answer. That does it for our second lesson. I will be recording another lesson here before I leave over our third lesson, which is probably going to be the longest video yet, over graphing quadratic functions. Remember that you have a Delta Math assignment over this, and it was due on August 11th, 2020, originally assigned on August 7th.